1. What is a filter dryer? Before understanding a filter dryer, it is important to first understand how a refrigeration system and an expansion valve work. Since the filter dryer is installed directly inside the refrigeration circuit, its main purpose is to ensure that the expansion valve or capillary tube operates efficiently without becoming blocked. Even very small amounts of dirt, debris, or moisture entering a refrigeration system can damage the entire system. This is where the filter dryer plays a critical role. A filter dryer cleans the refrigerant by removing solid contaminants and moisture, protecting sensitive components and maintaining system reliability. A filter dryer is an HVAC&R component designed to filter solid particles, absorb moisture, neutralize acids, and maintain proper system humidity. By doing so, it protects the compressor, expansion device, and other internal components from failure. 2. Why do you need a filter dryer in your HVAC&R system? A refrigeration filter dryer is essential because it absorbs water vapor from the refrigerant, preventing freezing and corrosion inside the system. Moisture inside the system can react chemically with refrigerant and oil, producing acids that damage internal components. In addition to moisture removal, a filter dryer traps solid contaminants such as copper particles, dust, and debris. Without a filter dryer, these particles can clog the capillary tube or expansion valve and severely damage the compressor. The filter dryer functions as both a filtering device and a drying device, protecting the most critical components of the HVAC&R system. Without it, problems like moisture buildup, acid formation, and refrigerant flow restrictions can seriously reduce system efficiency and lifespan. 3. Types of filter dryers. There are several types of filter dryers, each designed for specific system requirements and applications. Suction line filter dryers are installed in the suction line and are mainly used to remove moisture, acids, and contaminants after a compressor burnout. They protect the compressor from further damage. Liquid line filter dryers are installed in the liquid line before the expansion device. Their main function is to ensure that clean, dry refrigerant enters the capillary tube or expansion valve. Biflow filter dryers are designed for heat pump systems where refrigerant flow changes direction. A built-in check valve ensures proper filtration in both directions. Solid core filter dryers contain a solid desiccant core and offer high moisture and acid removal capacity. These are used in systems with high contamination risk. Loose core filter dryers are commonly used in smaller refrigeration systems and allow flexibility in maintenance. Burnout filter dryers are specifically designed to remove acids, sludge, and contaminants created after a compressor failure. They are essential for system cleanup after burnout. Replaceable core filter dryers are used in large systems such as screw chillers. The core can be replaced without changing the entire housing, making maintenance easier. Capillary copper filter dryers are compact copper dryers used in domestic refrigerators, small AC units, and freezers to remove moisture and debris. 4. Applications of filter dryers. Filter dryers are used in a wide range of HVAC&R applications. In refrigerant recovery machines, they remove moisture and contaminants during refrigerant recovery. Commercial and industrial refrigeration systems, such as supermarket display cases, cold storage units, walk-in freezers, and ice machines, rely on filter dryers for clean and dry refrigerant flow. Residential and commercial air conditioning systems use filter dryers to protect compressors and expansion valves. Heat pump systems also depend on biflow filter dryers to ensure long system life. Large HVAC systems like chillers and industrial refrigeration plants use replaceable core filter dryers due to high refrigerant volume and maintenance requirements. 5. Filter dryer and refrigeration units. Choosing the correct filter dryer depends on the type of refrigeration unit being used. Semi-hermetic condensing units commonly use biflow, burnout, solid core, suction line, and liquid line filter dryers. Commercial refrigeration systems typically rely on biflow and suction line filter dryers to ensure continuous, reliable operation. Large screw compressor systems benefit from replaceable core filter dryers, which allow efficient maintenance without replacing the entire unit. 6. Where is the filter dryer installed? In most refrigeration systems, The filter dryer is installed in the liquid line between the condenser and the expansion valve. This location ensures that refrigerant entering the evaporator is clean, dry, and free of contaminants. In air conditioning systems, the filter dryer is usually installed near the indoor coil to protect the metering device and ensure smooth refrigerant flow. This placement is ideal for removing moisture, acids, and debris before they can damage critical components. 7. How often should a filter dryer be replaced? Filter dryers should always be replaced during major system repairs, especially after compressor replacement or burnout. Under normal operating conditions, HVAC experts recommend replacing the filter dryer every 1 to 2 years. However, systems with high moisture or acid contamination may require more frequent replacement. Regular replacement helps maintain system efficiency and protects expensive components. 8. How do you test a filter dryer? A common method of testing a filter dryer is using a sight glass with a moisture indicator. If the indicator changes color, it signals moisture contamination and the need for replacement. Another method is measuring pressure drop across the filter dryer. A significant pressure drop indicates clogging or blockage. 9. What happens if you don't change the filter dryer? If a filter dryer is not replaced on time, dirt and debris can clog the filter, restricting refrigerant flow. Moisture buildup can react with refrigerant to form acids, leading to internal corrosion of compressors, valves, and piping. Blocked contaminants can reduce heat transfer efficiency in the condenser, restrict expansion valve flow, and reduce evaporator performance. In severe cases, compressor seizure and total system failure can occur. Restricted refrigerant flow also increases energy consumption, causes pressure imbalance, and leads to costly repairs and system downtime. Timely replacement and proper maintenance of the filter dryer are essential for long-term HVAC&R system reliability.